Welcome to another video from Adams Academy, an expert online tutoring service for high school mathematics. In this video, we solve questions from 2015 CBSE question paper from the lesson Some Applications of Trigonometry. First, we have a 1-mark question. A pole casts a shadow of length 2√3 meter on the ground when the sun's elevation is 60 degrees. Find the height of the pole. Let's draw the figure for this question. We have a pole whose height we need to find. Let's call that h. Let's assume the sun is somewhere over here and the shadow of the pole is here. The length of the shadow is 2√3 meters and this will be the angle of elevation of the sun. The angle of elevation is 60 degrees. We need to find the height of the pole. So using tan 60, from the triangle tan 60 is h by 2√3. So h is going to be 2√3 into tan 60. You know that tan 60 degrees is √3, so that's 2√3 into √3, which is 6. So the height of the pole is 6 meters. Next we have a 3-mark question. From the top of a tower of height 50 meters, the angles of depression of the top and bottom of a pole are 30 and 45 degree. Find how far the pole is from the bottom of the tower and the height of the pole. So there is a tower of height 50 meters. Let that be the tower. From the top of the tower, the angles of depression of the top and bottom of a pole are 30 and 45. So since it is angle of depression, it is clear that the pole is shorter than the tower. So let's have the pole here. The angles of depression of the top and bottom of the pole are given. Let's mark those angles. This is the angle of depression of the top of the pole. That's 30 degrees. So this is the tower and this is the pole, just so that we don't get confused. From the top of the tower, the angle of depression of the top of the pole is 30 and the angle of depression of the bottom of the pole is 45. So this angle here is going to be 45. Let us draw a horizontal here. This angle is going to be 30 degrees and this will be 45 degrees, right? Now let's frame the equations. Let's call this A, B, C, D and E. From triangle ACE, you can write tan 45 degree is equal to AC by CE. Now AC is the height of the tower and you know that's 50, so that's 50 by CE. And you know that tan 45 is 1. So you can write CE is equal to 50 meters. From triangle ABD, if you use tan 30, you can write tan 30 is equal to AB by BD. And that's 1 by √3 because tan 30 is 1 by √3. Therefore, BD is equal to AB into √3. Now if you look at these two equations, CE is 50 and BD is AB √3. In quadrilateral CBDE, you can see that CBDE is a rectangle. Therefore, CE and BD will be equal. So from equations 1 and 2, the left hand sides are equal. CE and BD are equal because they are opposite sides of a rectangle. Therefore, you can equate the right hand sides. Or you can write AB √3 is equal to 50. AB equals 50 by √3. Let's take one more look at the question. We need to find how far the pole is from the bottom of the tower. So they are asking us to find this distance CE. How far is the pole from the bottom of the tower? We have already found CE, that's 50 meters. So that answers the first part of the question. Now we need to find the height of the pole. The height of the pole is DE. And you know that from rectangle BDEC, DE is the same as BC. So all we need to do is find BC. You know that BC is equal to AC minus AB. And AC is the height of the tower, which is given as 50 meters. So that's 50 minus, and we just found AB is 50 by √3. So let's write that here. AB is 50 by √3. Now to compute 50 by √3, let's multiply both numerator and denominator by √3. So this becomes 50 √3 by 3. If you use the value of √3 which is given in the question, this becomes equal to 28.87. And therefore the height of the pole is going to be 50 minus 28.87, which is 21.13 meters. So that will be the height of the pole. The last question is for 4 marks. Two poles of equal heights are standing opposite to each other on either side of the road which is 80 meter wide. We have a road that's 80 meters wide and there are two poles of equal heights on either side of this road. So that's one pole and that's the other one. Both are of height. Yeah, we don't know the height. Both are of equal heights. Let's call that h. The road is 80 meters wide, so this distance AB is 80 meters. From a point P between them on the road, so let's have a point P here. The angle of elevation from P to the top of a pole is 60 degrees. So let this angle here be 60 degrees. And the angle of depression from the top of another pole at point P is 30. So the angle of depression from the top of the other pole to this point P, this is 30. And you know that this will also be 30 because they are alternate interior angles. So that's your figure. Let us call AP x. So we are taking the distance AP is equal to x. BP is going to be 80 minus x because we know the whole distance AB is 80. So if AP is x, BP has to be 80 minus x. Now using tan 60 degree is going to be h by x. If you look at this triangle, and you know tan 60 is equal to root 3. So h is equal to x root 3. That's one equation. And if you use tan 30 in the other triangle, tan 30 is equal to, you know that this height is also h. So tan 30 is equal to h by 80 minus x because BP is 80 minus x as we have seen here. And you know the value of tan 30, that's 1 by root 3. You need to find the heights of the poles. So you need to find h and the distances of the point P from the poles. So you need to find both AP and BP, right? From this equation you can write h is equal to 80 minus x by root 3. Now equating h from these two equations, x root 3 is equal to 80 minus x by root 3. If you solve this, you will get 4x equals 80 and x equals 20. So the distance of P from point A, this is 20 and the other distance here is going to be 80 minus 20, which is 60. So you have found the distances of the point P from the poles. That's 20 meters and 60 meters. Now we need to find the height of the poles. You can find that from this equation. The height of the poles is x root 3. H is equal to x root 3. That's 20 root 3. Since root 3 is not given in the question, it is enough if you write the height in terms of root 3. So the height of the poles is equal to 20 root 3 meters. And that's your answer. To watch more revision videos, please like our Facebook page and subscribe to our YouTube channel. For convenient and effective online tutoring in high school mathematics, register for a free demo on adamsacademy.in. Thanks for watching.